Good morning. My name's Robert, and as you see, I am somebody from Percona. Yee! Anyways, what I'm going to try to do is in the next 50 minutes, I'm going to do a whirlwind introduction of essentially 99.9% form of every form of replication that exists in Postgres. Now, the slides should be available, I think, through our system. And what I'm going to do is I'm going to walk through them. It's a bit like a story because I'm going to start at the beginning of how the replication started, and I'm going to build up each feature over and over. And basically the code is on the slides. As well, I've got a little script that I just run, and it does things, and I'll show you the results. I'll also show you the source code, and the reason is because they'll be slightly different from what you see on the slide, and it helps me make points to remind about issues, caveats, little techniques and tricks to keep in mind. So let me begin, and my big challenge is to talk without sounding like an idiot, and do it in a timely fashion that everybody gets it. Okay, so as I said, this is a walkthrough on essentially every form of replication currently supported in Postgres. And I will give a little caveat. Yesterday I was talking to Bruce Momjan, and if you know a little bit about the community, oh, some of you really know Bruce by the way you're shaking your head. Bruce told me that on Postgres version 16, they've actually been working actively, putting in what's called logical replication on standby servers. Now, logical replication is covered. When I come up to that, if I forget, remind me, because they've added a new capability, which is really nice. Okay, now, this, believe it or not, took me several hours to build out. This is a timeline. What you see on the numbers on the top are the versions of Postgres. What you see below are the forms of replication. I'm going to fill in a little bit of the gap of what it means. 2004, we had our first major version called 8.0. Now, it was supposed to have been 7.5, but we cornered Bruce in a corner and convinced him, no, too many changes are being made. This is going to be a brand new server. And he says, okay. So it became 8. What makes it special is for the first time it introduced what was called log shipping. Now, Postgres is ACID compliant. The mechanism that was used for ACID compliance allows for recovery, and it uses write-ahead logs. When they built in the replication, they had a long-term plan of building out the features. They decided to use the write-ahead log capabilities and to write the information in such a manner that the replication would feed off that. It was a nice, elegant little solution. When it first came out, you'll see them at the bottom here, and there's my little pointer there, warm standbys. We had what was called the ability of having one server was a primary. The second server was not even read-only. It wasn't capable. You couldn't log in. You couldn't access it. In the failover, you would promote it, and there was a couple of techniques. You had to have access to the server to do it, and it would recover. At that point in time, it would be read-write. When we got to 9.0, and there were several versions between 8.0 and 9.0. There was 8.1, 8.2, 8.3, 8.4. When we got to 9.0, we added another feature, hot standby, which was the first time where we had replication going to the server, and you could read the silly standby with queries. Mind you, it was still read-only, but now we could read it. Now, in between these two, it was still using log shipping. The log shipping meant that there would be a delay because you had to send the WALs, but the WALs would only be sent after the primary said, okay, I'm done filling it up. Now, at this time, this concept, slots, didn't exist. So we're noting it here, without slots. Between 9.0 and 9.4, we had streaming replication, which was dominated, without slots. 9.1, 9.2, notice the nice colors. You can tell the versions. Now, right about here at 9.2, we introduced a concept called cascading. So you'll see a nice little picture. and it says PG1, PG2, PG3. A cascading server is the ability to replicate from another standby server. It was a nice little concept, and it has a very practical use case. Imagine you have a 3-node cluster, data center 1. Well, you could have data center 2 have lines of communication, multiple lines, over to your primary in data center 1. Instead, send one line of communication. That line of communication would play proxy. So we would have our cascading server as the pseudo primary in our second data center, and the other ones would read off it. Very, very nice. And there's actually some interesting use cases when you do promotions because of that capability. So 9.4 came along, and we had with slots. Now, with slots dealt with a very practical problem. In the real world, our servers stop communicating for whatever reasons. Pull out the plug, somebody comes in, shoots it with the shotgun, hardware failures occur. At some point in time, there's going to be a reconnection. Well, up to this point, we're talking about the walls. When you go to streaming, the nice thing about streaming is the latency is very, very small. It's in milliseconds under ideal conditions. But when you break the communication, well, the primary only holds walls for so long, and then it goes to disappear. Now, there are alternate mechanisms, and when you get comfortable with all these concepts, it's amazing what you can cook up. But at some point, you're going to lose contact, and you have to have some sort of recovery mechanism. When they introduce slots, you suddenly turn your standbys into individual clients. They are like PSQLs or pgadmins. They're client applications that connect, and they have a relationship with the primary. If there is a connection break, the primary would note it, and it would hold on to the write-ahead logs. Instead of doing its normal practice of rotating the write-ahead logs, it would hold on to it, hold on to it, hold on to it. And then this would work great, especially when you had multiple standbys, because then it would track them individually. Once the communication was made, then it would throw it very quickly. Now, as I said, there are alternate mechanisms, and as we go through each individual type of replication mechanism, we can talk about that. Now, on the very bottom, you can see we've got asynchronous and synchronous replication. So at 9.1, right there, we had asynchronous. Difference between the two? High-speed communication, but they're not necessarily reflecting the same information change at the same time. Synchronous replication, your primary is not going to respond to the client that's making the DML activity or the DDL activity until it gets an acknowledgement. Now, when we cover synchronous replication in this demonstration, you're going to see there are rules. There are ways of how do we reconcile? How do we get acknowledgement? Does everybody, all the standbys do it? Is it only one? Is it a two? In what order is it done? Those kind of things we'll cover again. So we've got the asynchronous, we've got the synchronous, we've got without slots, we got with slots, and then in 9.4, we came up with logical replication. Up until 9.4, all forms of replication was basically, let's get everything on our primary somewhere else. Let's get a copy of it. Logical replication was the ability to be able to take a data subset, but it also offered another opportunity. It allowed us to create a process to do Postgres upgrades with minimal interruption between the primary and its client servers. When it's well synchronized, you logically replicate. You either do a portion of the data or you do all of the data, and then you do a little bit of magic, and then suddenly you switch. And instead of depending on the PG upgrade or whatever mechanism is being used for performing the upgrade, it would be there. Now, again, we'll go through the caveats, and from what I can see from your faces, this is, you're here like I am. When I said, I'm sort of checkmarking, yeah, I remember this, oh yeah, I gotta remember that. Yes, so we're just gonna go through the concepts and get this acquainted. All right, so here we go. As you know, in Postgres, there are a lot of runtime parameters for a lot of reasons. But there are only key parameters that you should pay attention. This is an example. The ones in bold are basically the ones that really you should pay attention for the different kinds of services that you're going to do. The others, they do make sense. They are there for a reason. Some of them are historical. For example, this little thing here called promote trigger file at the very end, that is old technology. It's old school. Now, for whatever reasons, the Postgres community has never deprecated a process. Old mechanisms are still in place.
For some reason, because people use it.
That is the cool part, because they all apply, and it is amazing when you have confidence, when you have control, you can handle any kind of situation by using a combination of the varieties of replication possible. All forms of replication that we've covered, that we are going to go through again, they are all actionable. They are actionable simultaneously. Okay, where am I here? Okay, so here we go, starting with our history. 8.0, log archiving. We have a primary. It's going to ship logs. This mechanism, it is still used. It is used in the cloud. It is used for point-in-time recovery, the ability to take a WAL, read it, and recover a server to any point in time. This was the first step. Let's make the logs. So here's the code. In order to do log shipping, the simulation is this. I'm going to simulate and create 3 servers. I'm going to use Linux containers, which I prefer over anything, including Docker. Docker is for nerds who don't know any better. In this case, we're going to use a simple mechanism of moving the WALs over. We're using SCP. Now, I had to do high-speed copies, and I actually measured this when I was doing backends, doing replication on servers that we were servicing for AT&T. And SCP, turns out it's very, very good. It's very redundant, but it's slow compared to other techniques. Rsync is faster, and the fastest technique is an extremely old school technique. A pass-through, standard input, standard output. Just pipe it right through SSH. It's about 1,000 times faster than SCP. And I was reading the metrics on that, which is amazing when you consider SCP is useful and is used so often when you consider how many reads and writes that little thing does. So in this case, okay, PG1, PG2, PG3. PG1 is our primary. We are logging in from PG1, which is right there, our little SSH PG1. We are going to generate public-private keys. The objective is to log ship the server, the WALs, to the remote server. Now, in the real world, you could do an NFS mount. You could put it to S3. This is nice. This is easy. It's simple to understand. We go through the routine of creating your keys. In this case, now, I've never run into actually anybody using passwords for real in a Postgres environment. They always use it without passwords. But you can configure Postgres to put passwords inside the configuration files. They are there. It's just that I've never seen it done. Okay, so we create our public-private keys. We copy our public key over to our remote server, PG2, and in this case also PG3 because we'll be using it later on as well. But right now we're focusing on PG1 and PG2. So the log shipping is, we are there on PG2 and we are going to make our target. So I log in, sudo as Postgres. Everything that we're doing in this case is all operations are under Postgres. We're using home, uppercase WAL, and I like the little switch P with make directory because it's good for scripting. It rewrites over the subdirectories nice and tidy. So because I'm using Linux containers, I just sudo as root all the time, and then I sudo as Postgres. It saves me a lot of effort, and I just go back and forth because I run the system CTL startup scripts. I try to follow the standard that's designed for the OS because that way it prevents having confusion. And I've often gone on to clients where they weren't familiar, especially when they were going from CentOS to Ubuntu or Debian, and there's a completely different way of doing things, so they just go back to the really old way of doing PGCTL, and it drives me crazy because then they have non-standard ways of locating their data cluster. Okay, so we make our directory, we sudo, log in, and we are going to make changes. Now, for my purposes, I'm just using the alter system. which means it's going to go in the PostgreSQL.auto.conf file. Now, for those people who do play with the configuration files, here's the order. Server starts up. It inspects. It's going to look for files. Then it's going to read configuration files. It reads first PostgreSQL.conf. If there's an include mention in there, it will read that. And then if there's anything after that in the main file, it keeps on going. After all that, it'll read PostgreSQL.auto.conf, which will override anything previous. And I have seen people get very confused when they work in large teams and somebody has a genius idea and puts it in a non-standard way. Okay, so alter system set archive mode to on. Alter system set archive command. Here we are, SCP. Notice %P, %F. %P refers to the full qualified path of where the write-ahead log is located. Where the server knows, that's where it is. %F is the fully qualified name of the WAL itself, not the path, but the write-ahead log. WAL keep size. This is a safety margin. This is also dependent on the version of Postgres. What it does is it forces Postgres to hold on to a certain number of WALs with the idea that, hey, I'm breaking communication. Good rule of thumb. If you have access, if it's an old school host, look at the timestamps between the oldest and the latest, and you'll know how much time you've got for a server break. Fine, oops. Then, WAL log hints. We aren't really using it. This is a good practice, especially when you're going to be using PG Rewind in your system. It's just good practice. So, some of these modes require restart. Some of them is a sig hop. The one that really matters for a restart is archive mode. Rule of thumb, and this was a fluke accident. When this came out, some person, some nameless denizen, wrote to the mail system and says, hey, you know what I'm doing? I'm using bin true for my archive command. And guess what? I don't have to restart the server. So everybody said, oh, duh, right, good idea. So if you set this to on, and you use /bin/true, you now have the ability to turn off log shipping at will with a single reload instead of restarting the server. It's a little trick. It's an old trick in the annals of ancient history, but it's a good technique. Okay, so carrying on. Generate the WALs, drop the database, create the database. Again, it's good for scripting, good practice. Most of my scripts are little bash scripts. I always like the concept of standard in, standard out, standard error. It allows me to use PSQL in with Postgres, and PSQL is probably the best tool to use because it catches mistakes and it tells you why it screws up. If you use other clients, it's up to those people who are designing that project. But PSQL is good, which is why I'm scripting it this way. So I'm populating a table, putting it in. Checkpoint. Forcing the WAL to be written, and I'm switching it. You don't need to do that. This is for our practices. Nice little trick. If you want to test something, PG switch WAL. It'll force the WAL to rewrite. The WAL is a bucket. It's an empty bucket. You're filling it with water, and when it gets filled, that bucket leaves. But you can make that WAL leave prematurely with that command. Okay. We then log in, and we check out the WALs. So at this point, I will just run my little environment, show you the output, show you the source code, and then we move on.
You get so much to cover. Do you have time for questions? Or should we ask them at the end, or see you in person?
I'm thinking it's going to be at the end. And again, I'll try to be complete as quickly as possible. I always put in more content than the time allows, which is a terrible habit. It's one of those quirks for people who always look at their computer and their wives bitch. Okay, so let's get this script going. And let me bring this out. There we go. And this is my setup. I've got a template container. I'm just stripping it out, copying it. And what I'll do is I'll run the first script, which will do log shipping, and I'll show you the source code. Then we move on. So right now it's doing its thing. One thing I've noticed over the years is data cluster is really small when you compare it to other database systems. Like I'm not comparing it to MySQL, but SQL Server, Oracle. Like I remember one time I was installing Oracle and it was a gigabyte large and there was nothing in it. Okay, so if you notice, the environment, PG1, PG2, PG3, and I've hard-coded the IP address. 11, 12, 13, respectively, to the number of the server. So we are focusing at this time on PG1 as a server, and PG2 is the target for the WAL log. So let me run our little first script. There we go. I'll run it, and then I'll show you the code. So what it's doing now is it's simply creating, setting it up, and it's going to populate with the table. And there you see at the bottom is their output. So this is at our target server. If I had more time, I would log on to PG2 and we would navigate, but everybody here is pretty damn smart by the looks of it. Okay, so let me show you the source code. Let me get this out of the way. And again, the reason why I'm showing it to you is because there's slight variations. It was convenient, but it's good to see that there's more than one way of doing something. Okay. All right, here we go. So that's my setup. Here we are. And I put line numbers to read it. Can everybody read the writing, or should I make that larger?
Larger, please.
Okay. Good? Okay. All right, so I'm showing you this because I'm showing you little tricks. And if it's one thing I really appreciate about talks, sometimes after 40 minutes, 15 seconds made it worthwhile. I hope you'll find one of those 15 seconds here. So, beginning of the script, I reinitialize, generate the key, and I'm using SSH pass. I'm using SSH pass so I can do the copies without inputting the passwords. Makes it nice for scripting. I then create my WAL directory on PG2. Notice the redirects, underscore EOF underscore, put it there at the end. There's my little LXC to log in and do whatever I have to do as root. And I'm navigating between PG1 and PG2 to set up everything. And then near the bottom, line 35, I'll scroll up on that. You'll see the generating. Now, for our purposes here, I'm using Postgres as much as possible just to simplify things. In the real world, don't. There's my table population. There's my checkpoint. There's my WAL, my switching my WAL to force the check so I can get it over there. And then I'm going to validate. Now, when the output came, you may or may not have noticed, but there was a slight delay. That was intentional in the script to highlight one very straightforward point. There's going to be a delay. Getting that log over to your target is a delay. So when we go to log shipping and replication by log shipping, you cannot depend upon having a timely synchronization of the system. And sometimes, depending how you configure the system, it could be a couple of minutes, it could be longer. If it's a quiet system, it'll time out before it'll sound off the wall. Okay, so I'm now going to move off to the next example and carry on with the description. So the next part is BaseBackups. Now, when replication by log shipping was first created, there was no utility. This utility, PG BaseBackup, didn't exist. What happened is we used an old school technique. We used copy. We used rsync, and even older technique. To create a copy of a production server, you used rsync. There was a trick. You have the server under production conditions, rsync. Is that target good? No. Once it's done, however it took, then you rsync it again. Because it takes less time, because during the time of the original rsync, especially it's multi-terabyte, you have to catch up. And then, when you want to make that server active, you rsync a third time, but you shut down the primary. This whole process of log shipping and replication was meant to stop that. So PG BaseBackup has all these wonderful controls and switches. This is the latest generation. The early generation had less options, less capabilities. So,
What version did that come out?
oh my God. I'd have to go back in history. Like I said, that flowchart, that took me hours because I had to go through the release notes to remind myself.
We're running 9.6, so.
Oh, I've got 9.6 horror stories. Okay, so basically, here's the concept. Source, target. You're going on your target server, you're logging in. Base backup is a client. It's behaving like a client. It's going to connect to the primary, and it's going to initiate a copy. Now, when it does that, the primary is told, hey, somebody's doing a copy, and it wants me to track the walls. Okay, so it's going to generate a label. This tells you the target, where it's going to go. This tells you format. Now, by default, I've never seen this used. It's just left alone. Max rate, I don't think anybody wants to slow down a base backup. I've never seen that throttled. The initial implementations of PG base backup, this switch did not exist. This is a convenience method that later versions of Postgres had, and what it does is, Postgres reads files before it decides what is it. Is it a primary? Is it a replica? So this generated runtime parameters adjusted explicitly for the purpose that, hey, I'm running as a standby. Table space mapping. This is a nice addition. Initially, it didn't exist. And this happened when you have inconsistent servers. I don't see it happen too often now. It happened back in the day because people would have different machines. They have different hardware configurations, and they had to compromise. Wall directory, again, this actually is a nice technique. When you use a wall directory, you're going to separate the walls from the data cluster. Everything by default goes into the data cluster with all its subdirectories. However, what happens when things fill it up? Well, once you fill up that data cluster, which should be a partition, because if it's not, you're shutting down the OS, by the way, it's going to shut down the server. Using this switch, you're segregating the walls. If you ever run out of space for your write-ahead logs, the worst that it happens is it's not going to behave nicely when clients connect. But your data cluster will remain integral. You won't lose existing data. It just means it won't work well with anything moving forward. That's the good fail-safe. That's why you do it. Also, especially when you have hardware capable of multi-channels, as for example a traditional RAID, that comes in handy. Okay, so wall method. When you perform a base backup, you have the choice. I'm going to perform a copy. Oh, by the way, what happens as it's working? Well, it's generating walls. You have the choice. If you've got the bandwidth, best practice suggests take the walls at the same time. It creates a second channel, and it copies the walls as they are being generated, as well as copying everything else. The advantage is that when you do start recovery on your standby, it's going to come up really fast because it's reading locally. If you don't, no big deal. What's going to happen is it'll copy, and then it'll say, okay, I finished the copy. If I start the server up, it will function, but I now have to catch up. So it'll then go to the primary and say, all right, please give me the rest that you have been generating while I was copying. That's the difference here between when you go, oh, where am I here? How come I lost myself? Yeah, that's the difference between fetch and stream. Fetch will do it at the end, stream does it concurrently. Best practice, I have not seen networks overwhelmed when you do stream, so work with stream. The only caveat though is the size of your target server. If you do stream and you've got a very large database, you're going to have to make some calculations. How much walls do I have to hold on to before I can start recovery on the target? That's the only issue. I don't see it happen too often. Machines are very large these days, but it is a consideration. Do it by default. It's a checklist. This I don't see too often, compression, gzip compress. You can control it. Normally I don't bother, but if you're really tight on walls, there's a rule of thumb. Anything that compresses works faster. Now at the bottom, checkpoint. Base backups do not begin until Postgres generates a checkpoint. This switch, assuming you're running this as super user, which you must, or have the proper privileges, then this will tell the server initiate a checkpoint. Otherwise, your base backup will pause. The reasoning is load. If you have heavy loaded system, if your system is sensitive and you are cognizant of that, you want to be gentle. You want the system to say, okay, now it's time for a checkpoint. Otherwise, you're going to force it a checkpoint, and that's it.
Sorry, momentary clarification. What will pause the server or the backup?
The backup. It will not begin. Newbies especially, when they started doing the base backup, they would see it, and they'd sit, and they'd sit. I said, oh my God, it's not working. I did something wrong. It's only waiting. And in the old systems, that switch didn't exist. You had to log into the primary, and you go in and say, checkpoint, enter. Okay, now, these issues here create slots. That's for stream replication. Without slot, that's synchronous replication. Again, we'll cover that. Labels, interesting. The first generation of PG-based backup, you could only back up one server. It didn't have the ability to do two servers at the same time. So they made a minor change. I think it was in the 8 series. And they added label, which meant now you could start a backup with PG2 and, oh, let's do another backup with PG3 at the same time. You just put different labels. Okay, no clean. That is good if you're trying to figure out why something's not going on because it's a failure. It just keeps the files. PG-based backup under failure conditions will just erase everything and start clean. No sync, again, don't have to worry about this. I will never use no sync because I'm not in a rush to have a good clean base backup. Progress, this is nice. When you do PG-based backup, especially in traditional conditions, where that means you log into a real host and you're doing this system, run it in a screen session because it's going to take several days. Detach the terminal from the screen session and, oh, by the way, run progress because then you'll know how much you got left. Now, what this does is it runs a calculation on the original data cluster. It does not run a progress prediction on the amount of activity. So it is an approximation. It is normally pretty close. The larger the database, the smaller the error. So that's where the progress diagnostics comes from. Slot name, again, we'll deal with that when we do replication. Verbose, old-timers, especially sysadmins, they like logging everything to see where they screwed up. Redirect this into a file. Otherwise, you don't need it because what it'll do is it'll just keep you summary information as it goes on. Version, very useful. Rule of thumb, if you have multiple versions of Postgres, first, never do replication between different versions. Second, if you do have a version of Postgres, always use the most recent version possible. Don't get confused. The vSwitch is so important for me because sometimes I have multiple versions that I'm testing and I have a terrible memory. Okay, moving on. Normal connectivities, I have a preference. See the D switch there? That is the full connectivity parameters. That is very nice for me, I found, because I can use the name, the user, everything, all on a single line. Otherwise, you can use the conventional, traditional way of individual switches. It's nice, especially also if you're a developer, because that's very similar to the invocations that you use for client applications that you're programming or designing. Okay, so, and that brings us to log shipping, our first serious replication. And we have been talking for 16 minutes. Okay, so here's the process. As you recall, we did log shipping down to PG2. The difference is PG2 is now going to read the walls. PG-based backup is what does it. The instructions by the invocation will copy the cluster over. When the copy is done, if it didn't have the walls and it started up, if you didn't configure it, you will have a genuine working read-write environment, which will automatically be out of sync with this one because it will only copy the walls that make it integral, that make it whole. All those walls after the time that you begin the PG-based backup is what's going to be here, and it's going to be read here. Okay, so let's see, bring that over. And yes, let's go through our scripting. So, best practice, always look to make sure that the silly thing can be read and accessed because Postgres, when you initialize a data cluster, goes to local loop 127.0.0.1 and it doesn't allow remote connectivity, so you want to check that out. Little caveat information. I like using netstat. Netstat by the distribution powers that be, they're deprecating that. I always put it in on purpose. They encourage you to use SS. The switches are the same, except you add a little 4 right there. You'll notice here, we've got IP version 6, IP version 4. Again, remember, Postgres is natively compiled to work on both. Linux containers, it actually uses both, and when you do name resolution, it uses IP version 6, which is always why I take the time to make sure that I can read using that, because I don't want to use IP addresses all the time. I just use name resolution. But it is a caveat because eventually, in your workplace, you are going to shift to IP version 6 if you haven't already. Okay, so good practice. Test your login. Now, we're in this demonstration using Postgres. Of course, when you do replication for real, you're going to have a user account designed specifically for it for security purposes. Therefore, you're going to log in. You're going to see it works. Bingo. There is a utility now in recent versions of Postgres called PG_IS_READY. It's a simple utility, and all it does is ping. That's it. Can I communicate? And it doesn't even make a formal connection. It's sort of an IP test connection. If the server's sitting in, it makes certain that what's sitting on that port is Postgres. If it's working, if it's available, fine. And it comes back.
No authentication?
No, it just tests. Do I exist? Yes or no? All right, server is connected on PG2, and I'm split hairs here. CentOS and Ubuntu. Red Hat, CentOS, they use the old techniques. The configuration files are found in the data cluster. Debian, they have a policy of extracting configuration files out of the data cluster and locating them there in the etc file, the etc file, which is a protocol for enhanced security. Postgres, super user, has the ability to read. You can open a file and read anything there. So if you give somebody Postgres super user abilities, they can go in and read anything in there. Red Hat configuration puts it in the data cluster. Ubuntu, Debian takes it out, so you can't read the configuration. You cannot alter the configuration, which is the big deal. Another thing, Ubuntu also supplies convenience functions, PG_whatever, which gives you the ability to administer entire clusters, different versions and different copies of the same version of Postgres. It's useful for you for doing administration. It's useful if you run multiple servers on a host. I find it useful when I'm doing testing. In my scripting, I use it because it's nice and convenient. Otherwise, you have to manually create things, which can be kind of long. Okay, so this is what it looks like. And you can see here, we've got two methods, method 1, method 2. This is to find out just to confirm everything that works. Systemctl, it's a good thing that you get comfortable with it. Systemctl, systemd systems, they read Postgres logs, but they read only the most recent 10 lines. So if there is a screw up or a long-term screw up, you may have to go into the logs themselves. Otherwise, it's just a simple confirmation. Okay, so here's our little replication. We go up to the top, and on PG2, we are going to remove any existing data cluster. Again, scripting purposes. RM switch RF. We perform our backup. You do it as the user Postgres. You can create a base backup using root, but then the cluster won't start. And I've done that a couple of times. And I won't say more than a couple, okay? So we do our login. Again, best practice. It would be a good idea to use the fully qualified path name. In this case, this is an Ubuntu implementation, and there's an assumption that it's the most recent version. In this case, I'm using 14. The reason why I'm using 14 is 15 has some really radical changes that I do not want to go into. But 14 is still very good. Now, here's the example of the D switch. Notice the invocation. Nice and tidy. And since it's a command line invocation, you can use the \, which makes things tidy. Notice the fast, notice the stream, notice L base backup, notice the D, the P, and the V. P is useful, L, D you need for certain. These ones are assumptions, okay? Remember, Postgres runs on assumptions. If you don't write it, it doesn't necessarily mean it's not going to work. It just means it'll use a setting that you might not like. Okay, Now, on the replica, remember, if you start up after the base copy, it will not be a replica. You must configure. Now, there's two ways. We're using PostgreSQL.auto.conf, and we're using a very lazy way. Raise hands. How many people here has actually read the PostgreSQL.auto.conf file? Opened it up. Okay. For those who haven't, if you open it, there's this comment at the very bottom. It says, do not edit this file. I find that the most ridiculous comment ever put in, because there's no way to create a standby host unless you go in and edit the configuration files. So in this case, to be cautious, we append. We don't rewrite the file, we just merely add to it. Now remember the rule of thumb I said about configuration. Postgres reads runtime parameters. If it sees multiple instances of the same parameter, it'll just say, oh, this is the latest one, I'll take that one. So if you write something and you change your mind, as long as it's the last one, you're okay. Okay, now, other things. Hot standby gives you the ability to read it. You can log in and perform queries. You do have the option off or on. When Postgres 8 came out and started doing log shipping, they kept in the old behavior of not allowed to read it. They just made a parameter up and they called it hot standby. Recovery target timeline, latest. When you do a failover, you read the write-ahead logs. Have you ever noticed it goes 000010000 and then it does a hexadecimal address? Okay, that 1 is the timeline. When you create a cluster for the first time, it is a 1. Every time you do a failover, the guys were smart. They assumed that you would not bother going into another directory for the write-ahead logs, because if you didn't, and if they didn't take this into account, you would be rereading old walls into the new promoted server, which would ruin the system. So every time there's a replication, a failover, it increments that little 1 by 1. 2, 3, 4, 5. That's how you know how many times a system's been promoted. You just count that number right there. That is called the timeline. And when that concept was created, one of the ideas by the people who backed up that point was the ability to perform complex recoveries. You come in, have a coffee, you're still not alert, you execute a command, you just dropped the table. 30 minutes later, hey, I just realized I just screwed myself. So you can recover that, you can use the mechanism, but if you have heavy-duty activities for DML operations, you might lose what happened in that interim. The timeline is it enables you to enable a complex process of going in, recovering the data. That was changed, and at the same time reintegrated into the old data that you deleted. That, I have never seen a talk on how to do that. Now, it is doable, it is complex, and the person who did it was figuring on making money doing that. So I don't know how many times that happened. A lot of times when it did happen, people just redid the base backup. Okay, so we are hot standby. Recovery target timeline is latest. Otherwise, it could be an integer value. Latest is the easy thing. It looks at the largest number that's available there. The restore command, log replication, you're going to read it. When Postgres reads WALs, it will first look in its own transaction log directory, the WAL directory. If it doesn't find it, and you have configured this, it will then go and say, ooh, I got to look in here. And by the way, this is the command to copy whatever's there over to here. Notice %F. That's the name of the wall. %P is the fully qualified path of your target host. So if you put it in a non-standard fashion, the server knows where it is. Even a standard fashion, they'll know where it is. So it's going to issue, and we're using a simple copy. That could be an SCP, it could be an rsync, it could be anything. The point is, you are copying. You are not reading it from where the log sits. You're taking it out and you're putting it over to the write-ahead log directory in the cluster. So that could be a move if you wanted to. This archive command cleanup, okay. At some point in time, all those logs, they're going to pile up and they're going to grow. This is a check. Normally it's about 10 minutes. Postgres will go over and look at the archive directory and says, Have I done everything that is in here? What's the oldest one that I know that I did? It'll read, it will have the number of the wall, and it will delete everything else that is older than that. It will only delete walls. If you have another file, a little README or whatever, it won't touch that. It'll only explicitly look for the write-ahead logs themselves. Everything that remains, it will say, hey, I need this, they're still relevant. Now, there's a safety factor. It actually doesn't go to the very, very recent. There's a little few walls that it won't touch. Okay, so all of this is done. And if you do all of this, it's still going to promote itself and be rewrite because you need this little thing right here. This is version specific. There used to be a file called recovery.conf. Recovery.conf no longer exists in the modern versions of Postgres. So what happened was when the file was present, it meant, hey, I'm a standby. Well, when they advanced it and they moved these parameters into the main configuration files, they lost their way of confirming, telling Postgres. So they cheated. They said, let's create a file. Call it standby signal. It's an empty file. You just touch it, oops, and it gets created. Without this, you could read every wall that's present. It will copy into it, it will ingest it. But the moment that there's no more walls in that directory, it will promote and become read-write. So watch out. I got stung that in the early days too. Okay. Here's the parameters. You can see how it goes. You can see the login. We're creating a table. And then we confirm replication. So I'm going to run my little script. And let's see how we're doing on time.
3 minutes.
Oh my God. I'm sorry, people. I've really underestimated the amount of time. Okay, I'm going to have to do it this way. I'm going to have to make available the slides. Okay, so what we're going to do then is I'm going to load up onto my system. Okay, let's do this quickly. Like I said, there's so much things I can say, but.
Well, actually, I have a question. I trust your scripts will work, so I don't need to see them work. But how do you compare PG backrest to what you're talking about?
PG base backup? PG backrest was about recovering a server with an accelerated technique of copying walls. It was the ability of leveraging the concept called point-in-time recovery. You recover a server to a point in time. Here are the steps. These utilities, backrest is one of them, was a convenience method. And it creates backups of your data clusters. Again, rules of thumb is you either have 2 copies or whatever. So over a period of 2 or 3 weeks, you'd have distinct copies, and then it would copy the walls. And these utilities, they did cool things. Like they were multi-stream, so we would run orders of magnitude faster than PG-based backup, which is single-threaded. And it would also compress the walls, which would make it faster. Now, I'm probably going to piss off the next person. So what I'm going to do is I'm going to go right now while you're watching. I'm going to upload this to GitHub, and I'll show you the path where it goes up, and I'll make sure it's working. So let's see if I can do this now. And I apologize. I talk too much stories, yes. Okay, let's get this out of the way. All right. First thing to do is close this. Let's close that. And okay, I need to. Okay, I need to go here, here, there. I don't need you. And GitHub. And let's log in. Yes. New. Replication. And yes. public, good, good. Create repository. Take the time right now. There's the path. So I'm going to take my file manager and copy over to it now. Let's see. And okay, I'm going to just make this disappear for a second. Sorry, I'm sorry. I'm really sorry. I didn't mean to do that on purpose. Okay, let's bring this up. I'm just going to go offline here for a second. And let's bring this back down while I get my file set up. All I can say is I should have drunk more coffee to talk faster.
There was too much content. This has to be a tutorial, but very rich for what you've provided.
Oh, I could tell you gossip stories, I'll tell you. Okay, let's see now. Let's pull in the files. I don't work with GitHub too much. Let's see, refresh my memory. How do I upload? Upload, pull requests, code. Invite. I'm trying to import. Let's see, is that import? No, that's not. Somebody work with GitHub. Refresh my memory. What's
It wants you to create the Git repository.
and all I want to do is upload the files.
So I actually don't know if you can do that.
Oh no, I did do it. I just couldn't remember how I did it the last time.
I don't know.
Okay, let's see. Okay, give me a second here. I really appreciate your patience. All right, here's how it's going to work. Everybody has the path. You don't have to see me do it. Take it as an act of faith. Now, I will upload the slides. I will upload the scripts. Just so that you know, the scripts uses Linux container, and it makes an assumption. It assumes that you have a template container created. It's a certain name, and that means like it had Ubuntu installed, and it had Postgres installed, and it had certain configurations. I would say, use the script as a method of understanding. If you really want to kill time, see if you can reproduce it for fun, but it'll take a bit of time because I don't offer the instructions. All right, so again, thanks for your patience. I apologize.